So if you step outside on a clear winter night and you look up toward the constellation Taurus, you'll see this, well, this tiny glittering cluster of stars.
Yeah, it's a very distinct little grouping, like a
Ah,
tiny dipper.
exactly. And if your eyesight is fairly good, you will clearly count 6 stars.
Just 6.
Right. But here is the wild part. For tens of thousands of years, almost every isolated ancient civilization on Earth looked up at that exact same 6-star cluster, and they told a mythological story about 7 sisters.
Yeah, it's always 7.
Right. And one sister is always missing. So today, we're figuring out why.
It's really one of the most compelling mysteries in cultural astronomy. I mean, it blends astrophysics with ancient human oral tradition in a way you just rarely see.
And that is exactly what we are exploring today. You are looking at the Pleiades, or Messier 45. Today's deep dive takes us through a really comprehensive Wikipedia article that maps out the astronomical, the historical, and, well, the cultural footprint of this specific star cluster.
It's a massive topic.
It is. Our mission here is to trace how a single group of young blue stars, which are just over 400 light years away, managed to act as this ultimate ancient global sky clock.
And spark a huge controversy in modern astrophysics, too.
Yes, that too. And somehow unite human storytelling across oceans and millennia.
You know, the sheer geographic spread of Pleiades mythology is really what makes this so unusual. We are looking at a shared human phenomenon that existed long, long before any concept of global communication.
Yeah, let's look at the map from our sources here because it's staggering. You have the Celts in ancient Europe calling them the Torardos, and then you cross the world to the pre-colonial Filipinos who actually used them to mark the beginning of their year.
Right, and if you look out into the Pacific, the Hawaiians know them as Makali, while the Maori in New Zealand, they celebrate their rising as Matariki.
Oh, right, Matariki. And then you jump over to the Americas, the Maya, the Aztec, the Quechua down in the Andes, various North American tribes like the Sioux and the Cherokee. They all had highly specific, deeply ingrained traditions for this one tiny patch of sky.
It really did.
It kind of forces the question, right? It was essentially the universe's most successful global branding campaign. Why did humans everywhere, completely isolated from one another by these impenetrable oceans and continents, all fixate on the exact same tiny patch of sky and invent stories about, like, sisters?
Well, it really comes down to the mechanics of human biology intersecting with the cosmos.
Oh, so.
So we are deeply wired to seek out patterns. That's just how our brains work. When early humans looked up, the night sky was, overwhelmingly chaotic. It's just a random scattering of luminous points.
Just noise, essentially.
Exactly. But the Pleiades feature this striking visual density. It's a tight, bright little knot of stars that naturally interrupts all that chaos. It just commands the human eye.
So it's a visual anomaly, and we feel this need to explain anomalies.
Yes, precisely.
But that doesn't really explain the storytelling aspect, right? Why do so many completely different cultures personify them as a family, and specifically as sisters?
That points to how we process social information. A close-knit group of objects in the sky naturally translates into a close-knit group of figures in our narratives.
Oh, I see.
Yeah, a family is just the most intuitive human structure to map onto a tight cluster.
Which brings us back to that mathematical mystery I mentioned at the very start. So in Greek mythology, they are the 7 daughters of the Titan Atlas and the sea nymph Pleione.
Right, the 7 sisters.
And almost universally, the global myths focus on 7 characters. But practically speaking, like we said, the naked eye only clearly sees 6.
Yeah, the famous lost sister phenomenon.
Right.
And what's fascinating is the myths almost always feature a built-in explanation for that discrepancy. Like one sister hides her face in shame, or she marries a mortal, or she's just lost to the darkness.
And the sources outline a really fascinating scientific theory for this, don't they?
They do, yeah. It's really cool. If we wind the cosmic clock back, say, about 100,000 years, the star named Pleione was physically further away from the star Atlas.
Okay.
So, to the unaided eye of early hunter-gatherers, Pleione would have been much easier to see as a completely distinct, separate 7th star.
Wait, really? 100,000 years ago?
Yeah. Consider the implications of that timeline. It suggests that the core of this widespread mythological story might not just be a poetic invention.
You're saying it's an actual memory?
Exactly. It could be an observed astronomical reality. Early humans saw 7 stars, encoded that into a story, and managed to pass that specific detail down through tens of thousands of years of oral tradition.
Even as that 7th star slowly drifted and merged into the glare of the others, That is an incredible intersection of folklore and orbital mechanics.
It really is, and their cultural momentum never really stopped either.
No, it didn't. Take Japan, for instance. Their 8th century records refer to the cluster as Mutsuraboshi, which means 6 stars. But in modern times, they are known by a word derived from a verb that means to cluster together. And that word is Subaru.
Yeah, a detail perfectly preserved in modern commerce.
Right. When several smaller Japanese companies merged to form a larger automotive corporation, they adopted that name and its 6-star logo.
It is wild to think that people are out there commuting to work with a Bronze Age astronomical reference sitting right on their steering wheel.
Totally wild. But, these stars weren't just characters in a story or modern corporate branding. They served a highly vital, practical function.
Absolutely. They were one of humanity's first pieces of essential technology. They were an ancient sky clock.
Yeah, the sources detailed the Nebra sky disk, which is this artifact found in Germany dating back to roughly 1600 BC.
It's a beautiful piece.
It is. It's a bronze disk inlaid with gold symbols. You have the sun, the moon, and right between them in a very prominent position is a cluster of 7 gold dots representing the Pleiades.
And you have to ask, why did a Bronze Age society take the time and resources to forge this specific star cluster in gold?
Right, why them?
Well, because around the middle of the 3rd millennium BC, specifically around 2330 BC, the Pleiades served as the marker for the vernal equinox. They signaled the start of spring.
And for an early agricultural society, that isn't just trivia.
No, it's survival. Knowing exactly when the seasons turn dictates when you plant your crops. Misjudging that transition could literally lead to famine.
So the mechanical precision was vital.
Right. The heliacal rising of the Pleiades, which is the day they first become visible above the eastern horizon just before sunrise, acted as a cosmic starting gun for the agricultural year.
And it extended well beyond farming, too. In ancient Greek, the very name Pleiades is believed to derive from the word plain, which means to sail. Because their rising marked the safe opening of the Mediterranean sailing season. And we see similar functional uses codified elsewhere.
Yeah, in early Mesopotamian treatises where they start the star lists. And in the ancient Hindu Atharva Veda, compiled around 1200 BC, where they formed the first lunar station to mark the new year.
They provided the structural baseline for ancient Arabic calendars as well. But I actually need to interject here, because the sources mention a celestial mechanic that really complicates this perfect timeline.
You're talking about precession.
Yes, precession. Over thousands of years, the Earth wobbles on its axis.
Right. Think of a spinning top on a table. As it spins, the stem of the top doesn't stay perfectly vertical, right? It slowly traces a circle in the air.
Yeah, I can picture that.
The Earth does the exact same thing, just over a cycle of about 26,000 years.
So because the Earth is wobbling, our vantage point from the surface changes. The background stars appear to slowly shift position over the centuries.
Exactly.
And meaning, eventually, the Pleiades stopped perfectly marking the vernal equinox. The math no longer lined up.
It drifted out of sync.
So if they were strictly a practical tool, why didn't ancient astronomers immediately discard them when the seasons drifted? Why keep using a broken clock?
Well, you are identifying the tension between scientific utility and cultural momentum. By the time the Earth's wobble shifted the stars enough to be problematic for agriculture, the Pleiades had become deeply embedded in human society.
Like beyond just planting seeds.
Right. They were tied to religious rituals, generational traditions, and cultural identity.
So human tradition essentially outlasted the scientific reality. The math changed, but people refused to update their calendars because they liked the story too much.
Exactly. The symbolic power carried them forward. They remained the cultural vernal point long after they ceased to be the mathematical one.
That is fascinating.
Yeah.
And it sets up our next major transition perfectly, because for millennia, our relationship with the Pleiades was defined by the limits of human eyesight. But that changes dramatically when we start shifting our perception of scale.
Yes, the telescope.
Right. In the winter of 1610, Galileo points his newly invented telescope at this mythical cluster.
And he completely shatters the illusion of the 6 or 7 sisters.
What does he see?
His sketches from that observation reveal 36 distinct stars. He proves that human eyes had only been picking up the brightest peaks of a much larger, much denser population.
So Galileo proves our eyes were lying. But even with early telescopes, scientists had a fundamental question, right? Were these stars actually a family, or was it just a trick of perspective?
Right, the optical illusion question.
Yeah, could it be like looking at 2 distant streetlights that appear close together even though one is actually miles behind the other.
To solve that, they had to move beyond optical tools and into mathematics. In 1767, an English clergyman and scientist named John Michell approached the problem using probability.
Which was a big deal, because before Mitchell, the general assumption was that stars were just scattered arbitrarily across the void, like paint splattered on a canvas.
Just totally random.
Right. So Mitchell runs the numbers on the Pleiades. He calculates the mathematical odds of these specific bright stars aligning in such a tight visual group entirely by random chance.
And his result was 1 in 500,000.
Wow. So he statistically proves they are a physically related family bound together in space.
Yeah.
They aren't an optical illusion.
Yes, they are a true physical cluster.
And this scientific progress brings us to 1771 and the famous French astronomer Charles Messier.
Ah, Messier.
Yes. She publishes this renowned catalog of deep sky objects, officially dubbing the Pleiades Messier 45, or M45. But if you read the history in our sources, this is actually an incredibly suspicious catalog entry.
Oh, it is a wonderful historical artifact of academic rivalry.
It really is, because Messier was a comet hunter. His catalog was specifically designed as a do not look at these list.
Yeah.
He wanted to map out faint, blurry objects so other astronomers wouldn't mistakenly think they had discovered a new comet.
And the Pleiades are the exact opposite of faint and blurry. They are glaringly bright and totally impossible to confuse with a comet.
Right. Adding them to the list makes absolutely no scientific sense.
None.
But Messier had a rival, Nicolas Louis de Lacaille, who had recently published a catalog with 42 objects.
Yeah.
Messier apparently just wanted a longer list.
He was padding his stats.
Exactly. He throws in the Orion Nebula, the Praesepe cluster, and the Pleiades to bump his final count up to 45. It's literally the 18th century equivalent of inflating your social media follower count just for the prestige.
It's such an amusing display of vanity, but the irony is really profound.
How so?
Well, Messier's arbitrary decision permanently branded the cluster as M45, and this bright, obvious object that he just threw in as filler would eventually trigger a massive crisis in modern astrophysics.
Oh, right. The cosmic distance ladder controversy.
Yes.
This is where the deep dive turns into a genuine scientific thriller. To understand the panic here, we first need to understand how astronomers measure distance. You obviously cannot string a tape measure from Earth to another galaxy.
No, you definitely cannot.
So astronomers use a ladder system.
Right. You measure the distance to a close object using direct geometry. Once you have that baseline locked in, you use the known brightness of that nearby object to estimate the distance of things further away.
So rung by rung, you calculate the scale of the universe. And the Pleiades are a foundational rung on that ladder. They are relatively close, and thanks to John Michell, we know they are a related cluster. If we know exactly how far away the Pleiades are, we can confidently measure the cosmos.
Yes. And prior to the 1990s, ground-based measurements provided a solid consensus. The cluster was determined to be approximately 135 parsecs away.
Let's give that number some real-world scale for you listening. A parsec is about 3.26 light years. So 135 parsecs is roughly 440 light years away.
Right.
Which means the light you see when you look up at the Pleiades tonight actually left those stars right around the time Shakespeare was writing his plays.
It's a great way to think about it, and that consensus held perfectly fine until the European Space Agency launched the Hipparcos satellite.
Okay, what was its mission?
Its primary mission was to measure stellar distances from orbit using parallax. This would circumvent all the distortions of Earth's atmosphere.
Let's visualize parallax for a second. If you hold your thumb out at arm's length, close your left eye, and then switch and close your right eye, your thumb appears to jump back and forth against the background of the room.
Right.
That visual shift is parallax. And the Earth does the exact same thing. We take a picture of a star in January, wait 6 months until the Earth is on the opposite side of the sun, and take another picture.
And then we measure how much the star appeared to shift against the deep background galaxies. It is fundamental direct geometry. It is considered completely foolproof.
But the Hipparcos data comes back and just drops a absolute bombshell on the astrophysics community. It states the Pleiades are only 118 parsecs away.
Yeah, they were suddenly 10% closer than anyone thought.
And in astrophysics, a 10% error on a foundational baseline is catastrophic, isn't it?
Oh, it's a nightmare.
But wait, how does a multi-million-dollar satellite simply fail at fundamental geometry? Did someone, carry a 1 instead of a 0 in the programming?
No, it wasn't a simple typo. It was a really subtle, systemic processing flaw. You see, Hipparcos was incredibly accurate for isolated stars. But the Pleiades are a dense cluster.
Ah, Okay.
When the satellite scanned that specific crowded field of view, the overlapping signals from so many tight, bright points of light created a micro error in the satellite's internal measurement algorithms.
So it was a bias unique to tight clusters.
Exactly.
But before they figured that flaw out, panic set in. Because it's like, imagine you're building a house, right? And you realize the tape measure you used to build the first floor is missing an inch. You suddenly have to question the structural integrity of the entire skyscraper.
That's the exact scale of the problem they were facing. The basic laws of stellar evolution were under threat. If the Pleiades were truly 10% closer, the stars in that cluster were significantly less luminous than our foundational physics models dictated.
Which means everything else is wrong too.
Exactly. If the physics models for our closest neighbors were wrong, every subsequent rung on the distance ladder was broken. Estimations for the age, the size, and the evolution of the whole universe would have to be entirely rewritten.
That is a massive headache.
Oh.
So the scientific community scrambled. Our sources show they spent years bringing out the heaviest astronomical artillery available to either verify or debunk the Hipparcos data.
Oh yeah, they threw everything at it.
They pointed the Hubble Space Telescope at the cluster. They utilized very long baseline interferometry, which is where they link radio telescopes across the globe to create an Earth-sized synthetic antenna.
And later, they analyzed data from the new Gaia satellite.
And what did they find?
Every single one of those independent, highly advanced methods pointed back to the original estimate, roughly 136 parsecs.
Wow. The collective sigh of relief from astrophysicists must have been deafening.
I'm sure it was.
So the Hipparcos data was proven flawed, and the universe remained the size we thought it was.
Yes, thankfully.
So, having mapped out where they are and their amazing cultural history, I think we should look at what the physical reality of the Seven Sisters is today. What is the cluster actually made of?
Well, it is an open cluster dominated by hot, extremely luminous blue stars. And in cosmic terms, they are practically newborns.
Really?
Yeah, the entire cluster formed within the last 100 million years.
Wow. To put that timeline in perspective, the dinosaurs died out 66 million years ago. So when a Tyrannosaurus rex looked up at the night sky, the Pleiades barely existed as a cohesive group.
Right, it's very recent. And alongside those bright blue stars, the cluster hides a massive population of much dimmer objects. Up to 25% of the cluster's population consists of brown dwarfs.
These are objects similar to the famous Tide 1, right?
Yes.
Brown dwarfs are often called failed stars. They have less than 8% of the mass of our sun, meaning they lack the immense gravitational crushing force required to ignite standard hydrogen fusion in their cores.
So they just glow faintly from the heat of their initial formation.
Right, but our sources highlight that these failed stars are actually a vital tool for astronomers to calculate the cluster's age.
They are. They function as a cosmic stopwatch, utilizing the element lithium.
Wait, how does a lack of fusion make them a stopwatch?
Well, lithium is an incredibly fragile element. In standard, massive stars, the internal temperatures are so high that lithium is rapidly destroyed by nuclear reactions shortly after the star forms.
Okay, that makes sense.
But brown dwarfs, lacking that extreme core temperature, retain their original lithium for much longer. So by observing the highest mass brown dwarfs in the Pleiades and checking if they have burned through their lithium yet, astronomers can calculate an incredibly precise boundary for how much time has passed since the cluster formed.
Because we know exactly what temperature and pressure are required to destroy lithium.
Exactly. It's a chemical timer.
That is brilliant. And that gives us the firm age estimate of roughly 115 million years. Now, we have to address the most famous visual feature of the Pleiades. Anyone who has seen a long exposure photograph of M45 knows the image I'm talking about. You have these brilliant blue stars wrapped in a stunning, wispy, glowing blue fog, which is called reflection nebulosity.
It's iconic.
It is. And the intuitive assumption is that this dust is the stellar nursery, right?
Yeah.
Like the leftover gas from which these stars were born. But the sources state that is completely wrong.
Yeah, it is a very persistent misconception, but given the cluster is over 100 million years old, the immense radiation pressure from those young, hot stars would have blown away any residual birth material tens of millions of years ago.
Wait, so this beautiful dust cloud illuminating these stars has absolutely nothing to do with them?
Nothing at all.
Are you serious?
I am. The cluster is currently passing through a completely unrelated, particularly dusty region of the interstellar medium. The stars and the dust are moving along entirely different
Oh,
trajectories.
wow.
Yeah, the dust is actually flying past the cluster at roughly 18 kilometers per second.
So it is essentially a cosmic photobomb.
Yes.
Just a random intersection of matter that happens to look incredibly photogenic from our vantage point on Earth.
It's pure serendipity. And, well, it's temporary, too,
Temper.
because the gravitational glue holding an open cluster together is relatively weak.
Right, because the universe is dynamic. Everything is in motion.
Exactly. The Pleiades are currently drifting through space toward the feet of the constellation Orion, but as they travel, the tidal forces of the Milky Way are tearing at them.
And the sources map out a pretty dramatic final act for them. Over the next 250 million years, gravitational encounters with giant molecular clouds, passing stars, and the pull of the galaxy's spiral arms will systematically strip the cluster apart.
Yeah, the Seven Sisters will be physically separated and scattered into the broader background of the Milky Way.
The cluster will just cease to exist.
It will.
Wow. So to look back at the journey we've taken today, we started with a Bronze Age sky clock marking the new year. We traced a shared human mythology of seven sisters that somehow defied oceans and isolated cultures.
We tracked humanity's shifting perception of scale, too. From Galileo breaking the optical illusion to Messier's pretty petty catalog padding.
Right. And then we explored a modern astrophysical crisis where a geometry error almost broke our understanding of the universe. And we end with this temporary grouping of hot blue stars and brown dwarfs, briefly illuminating a passing cloud of dust.
It really highlights how deeply interconnected the physical mechanics of the universe are with the evolution of human knowledge.
It does. So the next time you step outside on a cold night and spot that tiny misty dipper in Taurus, consider the sheer weight of history attached to it. You're looking at the exact same light that guided ancient Mediterranean sailors, signaled the spring planting for the Maya, and thoroughly terrified modern scientists trying to measure the cosmos.
It's a lot of history for six little stars. But, it leaves us with a pretty provocative thought about the future, too. Well, we know the physics. We know that in 250 million years, those stars will be completely dispersed across the galaxy. If human descendants, or whatever we become, are somehow still around to observe the night sky then, there will be no cluster to look at.
It's a little sad to think about.
It is. Will they sift through our digital archives, study our ancient bronze nubra discs, and read our global myths of the Seven Sisters, and wonder what it must have been like to live in a privileged era?
A time when those lonely, scattered stars used to hold hands in the dark.